Okay, here are solutions for, what is this, perfect problem 6 for math 95. We're given this big mess and has to simplify it basically. And it even kind of takes you step by step. So let's see, step 1, it says simplify, I don't know why that's not capitalized, the denominator by first distributing the square root of 2. In other words, square root of 2 times the square root of 150 plus the square root of 54. We can simplify that. We can take this root 2 and distribute it to both of these terms. So we get that that's just the square root of 300 plus the square root of 54 times 2, which is 108. And then add these two things together. Adding up 300 and 108, it's not easy. In fact, you can't do it immediately. You can't just say 300 plus 108 is 408. What you could do is find the prime factorization of both of these numbers. So 300, I don't know, 3 times 100 would be one way to break that up. And 100 is 10 times 10. And 10 is 2 times 5. So what we have is that 300 is 2 squared for this 2 and this 2 times 3 times 5 squared. And similarly, 108, I run out of room here, is, well, let's see, it's an even number, so it's 2 times something. In this case, that something is 54. And 54 is 9 times 6. 9 is 3 times 3, and 6 is 3 times 2. So we get that 108 is 2 times 2, in other words, 2 squared, times 3 times 3 times 3, times 3 cubed. And so now we can simplify, maybe I'll switch back to green. We can say the square root of 300, break that up into 2 different radicals. Well, actually, let me show one more step in there. We can say that's the square root of 2 squared times 3 times 5 squared. And the square root of 108 is 2 squared times 3 cubed. And now we can break both of those up. Good radical, bad radical is what I called it in class. Put all the perfect squares over here. So I have 2 2's, I can put them both over here. I have just 1 3, it's going to go over here. I have 2 5's, so they'll go over here. And then I got 2 2's again. Pairs go on this side. 3 3's, so I can put a pair of them over here, but then I'm left with 1 over here. And the reason you break them up like that is the square root of 2 squared is just 2. Square root of 5 squared is just 5. Square root of 2 squared again is 2. Square root of 3 squared is 3. So what I get is that this mess in the denominator is really just 10 root 3 plus 6 root 3. In other words, it's 16 root 3. So that was a lot of work and I'm still not done. That's all just step 1. Unfortunate, but okay. Step 2. Rationalize by multiplying the numerator and denominator by the appropriate number. Okay, in other words, since I've simplified the denominator, what I now have is this is the square root of 3 plus the square root of 27 divided by 16 square root of 3. But this is not done. This isn't simplified. And the reason it's not simplified is because we don't leave square roots in the denominator. We want to rationalize the denominator. So in order to make it so I don't have any square roots in the denominator, I got to multiply the numerator and the denominator by the square root of 3. That'll get rid of this square root of 3. And if I do that, what I get is 16 times 3 down here in the denominator, 16, and then root 3 times root 3 is just 3. And then in the numerator, well, I guess this is the end of step, well, okay. Step 2 really technically ends at this step. I put the square root of 3 here out in front just because I know later I'm going to distribute it and I'm used to it seeing it out in front. You don't have to. You can do it however you want. If you want to, you could say 16 times 3 is 48. I don't know. Sure. 48. And then in the numerator, I got root 3 times root 3 plus root 27. All right. Step 3. In step 3, it asks me to distribute the numerator, distribute that number, geez, can't read, distribute that number, specifically the square root of 3 right here, into the 2 terms in the numerator, then add them up. Okay, so it's kind of repeating step 1. What I do is I say square root of 3 times the square root of 3 plus the square root of 27 is really just the square root of 9 plus the square root of 81. 3 times 3 is 9. 3 times 27 is 81. But these are both perfect squares. This is 3 plus 9. In other words, this is 12. So what I now have is my numerator is 12, this thing up in the numerator, and the denominator is 48. So for step 4, I say square root of 3, well, sure, I'll just say, yeah, I'm going to pick this up. Okay, so I'm going to go back to red so it matches up. Where I left off in step 2, I had this mess. However, in step 3, I figured out that the numerator here is just 12. So really, this is just 12 over 48. And that reduces because 48 is 4 times 12. So we cancel out these 12s, and what I am left with is just 1 over 4. Now, I think there's some sort of sports reference telling you to, let's see, the answer should be a fraction. Okay, it is, which is equal to the fraction of games that this postseason in which my beloved Warriors scored over 110 points. Okay, this happened twice. It happened in 2 of the 8 games. And 2 divided by 8, sure enough, is 1/4. Looks like everything worked out all right. So that is the end of this perfect problem.